Hello, my apologies. It seems that sharing the screen was a little bit too much for my computer. Yeah, and I hope that you can see it now. So we have several interesting posters, 8 to be precise, in this session. I'll try to briefly introduce them all. So the first one is from the Northeastern University, and here the authors demonstrate vulnerability of XC protocols on multi-tenant FPGAs by developing an attack on this protocol, and then they try to also mitigate it by proposing an integrity checking framework. The next poster is from Villanova University, where the authors propose an ultra-lightweight FPGA implementation of the binary ring learning with errors post-quantum cryptography algorithm. The next poster, is from the University of New Brunswick, where the authors propose a method to integrate IOSIS with Odin2 in VTR in order to benefit simultaneously from both of the mappers, where IOSIS has great support for newer standards of Verilog, whereas Odin2 has very powerful technology mapping capabilities. The following poster is from the University of Southern California, and here the authors propose a novel model accelerator architecture co-design method for graph neural network acceleration on FPGAs. The following poster is in a sense related to this one, because here the authors propose an efficient and flexible GCN accelerator architecture, and GCN is a core computation unit in deep learning on graphs. Now, because this architecture is tuned towards processing small graphs, it is primarily used for graph similarity computation, as the title says. The next poster is from the University of Rhode Island, and this work aims at protecting the die-to-die interconnections of a system in package by creating and utilizing the metastable state of flip-flops to detect small phase delay changes caused by a microprobe. The following poster is from the University of Pennsylvania, and it introduces a framework for defining partially reconfigurable functions at the C level, and then it automatically generates appropriate floor plan constraints for these functions, so that in subsequent function refinement, it can achieve from 3 to 10 times runtime reduction compared to synthesis or compilation with Vitis. And finally, the last poster in this session is from the University of Kaiserslautern and the University of Stuttgart, where the authors develop a system for efficient retraining of the receiver of an autoencoder, depending on the conditions of the channel. And this enables great improvements in communication systems performance, and also the authors state that their FPGA implementation vastly outperforms the comparable CPU and GPU implementations. I hope that I was audible, that there were no technical issues, and I invite you all to join as many poster sessions as you can, and you can find links below this video. Thank you.